Okay, so I've got the picture here. This says what it's got. First off, it's attached to two different parts of the string. So it's attached, it's not smooth, so I've got a tension going up here in the string, and that's at AP, so that's 5 newtons. And I've got tension going down here, which it asked me to find out in part B, so that's T going down there. I need to get all the forces on this thing, and so I've also got going down here the weight, which is 0.3 G. And that's all the forces. I'm going to change away from green. I like putting the angles in. This one here goes back 60 and up here. So this angle there is 60. And if I go up here, this angle here, it's a Z angle, or alternate angle, that's 30 degrees. Now I can start working things out. Tension in string B. Well, it's not moving up or down, so therefore that I can resolve vertically, and I can have the upward force equals the downward force. Since the downward force I'm trying to find out here, I'm going to have a downward force equaling the upward force. What have I got going down? I've got the whole of the 0.3 G, and I've got the T times by, I've got this curve, this component, pink component going back in there, and that'll be T cos 60. So I've got that plus T cos 60, and that equals all of the up bit, and that'll be 5, and that'll be 5 cos 30. And that'll work out that T equals 5 cos 30 minus that 0.3 G divided by the cos 60. And so T will equal 2.780254. So that will equal 2.78 newtons to 3 significant figures. And that's part 1 done. Part 2 wants me to find the angular speed, that's omega. So to do that, I'm either going to have to use that velocity equals r omega, or the acceleration equals r omega squared. Right, this one here, I'm going to have to get a formula for acceleration. I'm going to have to resolve into the center, and acceleration equals r omega squared, or v squared over r. It's worthwhile always being both. So I'm going to have to resolve into the center of the circle, and that says the resultant force equals the mass times acceleration. What have I got going inwards? I've got the component going in there, so I've got 5, and it's this component here, which will be 5 sine 30, plus my T sine 60. T is, I just worked out 2.78. I'm obviously going to keep more accuracy, but I'll write it down as 2.78 sine 60. And that will equal my mass, which is 0.3, times by the acceleration. And I know the acceleration is r omega squared, so it's times by the r. I need to find out what r is. The radius, I'll do it in red. I've got to work out the radius there. That's a right angle triangle, and so that's going to be, that's 0.4 down there. That length there is going to be 0, or r is going to be 0.4, and it'll be sine 30. That's a half, so that will be 0.2. So it's going to be 0.3 times by 0.2, which is the radius, times by omega squared. And that's what I'm going to have to work out. So omega squared will equal 4.9075506 divided by 0.3 times 0.2, which is 0.06. That equals 81.7925. That's what omega squared equals. So omega equals 9.04392111, which equals 9.04 radians per second. So rad per second. And that's to 3 significant figures. That's part 2. Part 3, I've now got to work out the kinetic energy of P. So kinetic energy equals a half mv squared. So obviously I'm going to need my formula with v squared, and so I'm going to use the acceleration from here. Both of these are the same, so I know that r omega squared is exactly the same as v squared over r, and I want to know what v squared is, so if I times both sides by r, that can be r squared omega squared equals v squared. Now I can work out the kinetic energy really easily. It's a half times the mass, which is 0.3, times by the radius squared, that's 0.2 squared, times by omega squared, which is 9.04 squared. Of course I could say it's 81.7925 because that's what omega squared is. And if I work that out, that gives me 0.490755 joules, which equals 0.491 joules to 3 significant figures. And that's question 6 done.